composite functions. When the output of one function is used as the input of another, we call the entire operation a composition of functions. For any input x and a function f and g, this action defines a composite function, which we write as fog, or FOG, such that the fog of x equals f with g plugged in for x. The domain of the composite function f of g is all x, such that x is in the domain of g and gx is in the domain of f. So it gets a little complicated when talking about the domain sometimes. We'll get into that with some problems below. It is important to realize that the product of function fg is not the same as f of g, f of gx. These are different. This isn't a times, and that's what it's getting at, because in general, f times g is not equal to f of g, and that's true. So anyways, let's take a look at the problem below here, and we think about the definition of this. It says, for the following exercises, use each pair of functions to find f of g and g of f. So we'll start with number 13. So if we're going to find f, and I'm just going to write the original notation for this so we can get used to seeing it. So this is f of g of x. So this simply means, and again, this isn't a multiplication here either. Sometimes people think they do this f and g thing and then times it by x. That's not how that works. This notation is similar to when I see f of x like this. So this notation, this doesn't mean I'm taking f and times it by x. But the name of this function here is f of g. And the name of this function is f. So that's the idea here. So if I'm going to take f of g of x, that means I'm going to take my f function, and I'm going to take my g function, and I'm going to take that g function and plug it into the f wherever I see x. So the f function, I'm going to keep purple here. What I'm going to do is I'm just going to take this middle out for a second. And I want you to see how this works. So I'm going to take the f function. So I have a square root, and anytime I see an x is when I'm going to plug in g of x. So I see an x in there. So I'm going to plug in g of x, which is x squared plus 3, which means I didn't extend this square root far enough. So there it is. And then I have a plus 2. So that's what that means. So anywhere I see x, I'm going to plug in g of x. And for this problem, g of x equals x squared plus 3. And that's what we see here. So now, can we simplify this at all? No. So this would be the actual answer for this problem. So these aren't very difficult to do, but we have to understand the notation. All right, let's take a look at number 16 now. All right, so I have f of, and I'll use the same notation again. I was going to put the other notation in, but no, let's keep it consistent here. So I'm going to deal with the f of g here. And this is going to be f of, and I'm going to do the same thing with my g of x in another color so you can see the clarity here of what we're actually doing. So with f, I have 1 over, I ran into an x there. So I have to put in g of x, which is 7 over x plus 6. And then I have a minus 6. So this is what the new function is going to look like. This is what f of g would look like for number 16 here. So now we can simplify this because 6 minus 6 is 0. So we really get 1 over 7 over x, which this does simplify some more because I take the top when I'm dividing with a fraction, I then flip the bottom and multiply. So this is actually going to be 1 times x over 7. And get used to that idea of multiplying by the reciprocal. It comes up a lot. The faster I get used to that, the better off I am. So then what this then is going to equal is x over 7. So we just did a couple of compositions. Now the directions also said find g of f. So let's try that one now. So for g of f of x. I'm still going to do number 13 here. I'm going to go with that one. That's why I left the answer for that one here. So now keep in mind, now my g is going to be the function that I'm going to plug something into. And then my f then is going to be what I'm plugging in for x and g. So then this is going to give me, right away I run across a x. So that x is going to be square root of x plus 2. And then when I look at the g now, I have that x squared plus 3, so that needs to be a little squared up there because this here is replacing my x. All right, so then I have a plus 3. Better 3 than that. There it is. So then I can actually square this first piece here because there's a squared there. And we should be able to do that and simplify it a little more, possibly. So then this is going to be x plus 4 square root of x plus 4 plus 3. So then our final answer for this one is going to be x plus 4 square root of x plus 7. So this would be the answer for g of f. Now again, remember, this was number 13. Both components here. So now we're going to finish up the second component for 16. So now we're going to do g of f of x for number 16. So this is 16 here. And again, I'm going to plug in f of x wherever I see x in g. So this is going to equal. So again, we're starting with our g here. So this is our g function here. So I'm going to start with the 7 over, and I ran into an x there. So in that place, I'm going to put f of x. And that's going to be 1 over x minus 6. And again, that's exactly what we do. We don't change anything about it, no matter how crazy it looks. I'm just plugging it in for x. Now again, let all the math work itself out, but that's the idea here. So now what we're going to do here is we run across the same problem we had in the other one, where I have this 7 divided by this fraction component, which is really a rational expression, but same characteristics. So I'm going to have to flip the bottom and multiply. So that's going to result in 7 times x minus 6 over 1 plus 6. So then this is going to simplify. Anything over 1 is just the number itself. So I can just call this whole thing x minus 6. So really I have 7 times x minus 6, this distributive property there. So that's going to be 7x minus 42, and then I have this plus 6 on the end. So then our final answer then is going to be 7x minus 36. So there's our final answer for g of f for number 16. So that's what it means to talk about composite functions, to find composite functions, and that's it.